Hi, and welcome to my supplemental on inequalities. And here are the four inequalities that we deal with in seventh grade math. This one's called less than, so denoted by an open dot on a graph. Less than or equal to, that is a closed dot on a graph, and I'll show that to you in a moment. This one's called greater than, and this is called greater than or equal to. And I'll start with a little, I guess, perhaps an equation here. X is equal to 3. Well, what number will fit for X? In this case, only one number will fit for X, and that is the number 3. So on a graph here, I would say, okay, I'm going to graph the solution for X, and that number is 3. That's the only number that will work for X. Let's progress on to these inequalities. And just to let you know, Inequalities. Inequalities. So they're unequal. They're not equal in most cases, unless you have that extra little sign right there that could be equal to, but they're unequal. So these might be called equalities or equations as we call it, but these are inequalities. So this side is supposed to be less than, because that is right here, is less than 3. Now, in this, there is not just one answer. Yes, we could put 2 in here. 2 is less than 3, but also is 1 and 0. And any 1.5 is smaller or is less than 3. Any negative number is less than 3. There's an infinite number of answers here. And so when we have a graph here, we are talking about numbers less than 3. So less than is an open circle. That means I'm not including 3, but anything smaller than 3 will work for X. And this covers the 2 and the 1 and anything in between 2 and 1, any decimal, any fraction, and so on. And it goes into the negative numbers as well. Let's compare that to this inequality, where we have X is greater than or equal to, 3. So what number will fit here? Well, it can be equal to 3. So we could have 3. And now this is a closed dot. That means it's including 3. 3 is part of our answer, whereas 3 was not part of our answer here. And greater than or equal to. Okay, so it could be 3, but it also can be larger than 3. And that is anything 4, 5, 6, 10, 10 and a half, 10.25, anything larger than 3, any decimal, fraction, or whole number larger than 3 will work for X. So these numbers are said to be the solutions for X. We can put it in for X and we'll get a true statement. For instance, 4 is right here. So if I put 4 here, 4 is a solution because 4 is greater than 3, and that's true. But if I put something like 0, if I put 0 in for X, that's not part of my graph. 0 is, if I have 0 greater than or equal to 3, that is false. And so that gives me a false statement in my solution, in my final statement there. So this only covers the, when you substitute the numbers in, they are true statements. Now let's get a little more complex. So this is usually 6th grade material here, but let's move on to 7th grade material. And now we have equations. So here we had just a statement here. Now we have an equation, and we've stepped it up a bit. We have a number plus 4 is equal to 6. Well, to solve this, we usually use the inverse operation. We do the opposite of adding 4, which is subtracting 4. And we do that to both sides of the equal sign. And we have the number X is equal to 2, because 6 minus 4 is 2. And when I graph this, I have a closed dot on 2, because I'm talking about my answer is exactly that number right there. It includes that number. And when I put 2 in for X, 2 plus 4 is 6. Super easy to see. And so this has one solution. But when I go to an inequality where they're not supposed to be equal to each other, this side's supposed to be bigger or greater than 6. It'll look just like the same thing. I will subtract 4. So in this respect, Inequalities in equations are treated the same way. We would solve them the same. X is greater than 2. But now the answer, this means X can only be 2. But this means only numbers greater than 2 will work in our original inequality. And so I'll graph this. It's an open dot, open circle, which is that right there. And it's numbers greater than 2. They go in this direction. This is a graph of the solution. And here's the solution. Now, if I place a number here, what number belongs here? Anything larger than 2, but not 2. See, 2 is not part of the answer. If I put 2 in here, because here it's not including 2, but if I put 2 in here, 2 plus 4 is 6. And you have to think, well, is 6 greater than 6? No. 6 is equal to 6, so 2 doesn't work. But anything bigger than 2, like 3. 3. And 3 is part of my graph here. 3 plus 4 is 7. And 7 is greater than 6. So that number from over here gave me a true statement. But again, if I have 0, 0 is not part of my graph here. 0 plus 4 is 4. And 4 is not greater than 6. Let's step it up a little bit more. We have this. A one-step inequality where I have 3x is less than 15. To solve this, I use the inverse operation. I divide by 3. These cancel, and x is less than 15 divided by 3, which is 5. Okay, so what this means is anything smaller than 5 will work in my original inequality, which is 3 times x, and I'll just put this in parentheses right now, is less than 15. So that's 3x, all right? But that x can be substituted for some number smaller than 5. A number smaller than 5 is 4, so I'll put that here. So this means 3 times x. This will mean 3 times 4, because now x is 4. 3 times 4 is 12. Yeah, and 12 is less than 15. But if I choose, so that's choosing any number less than 5. I mean, shoot, I could have negative. Oh, isn't negative 4 less than 5? And 3 times negative 4 is negative 12. And negative 12 is less than 15 still. But if I choose something larger than 5, not smaller than 5, but if I choose something larger than 5, like 6, 3 times 6 is 18, and 18 is not less than 15. Let's go to this. If I divide by 3 again, because I'm multiplying by 3, I divide by that same number, and they'll cancel, and x is less than negative 15 divided by 3 is negative 5. So now I choose something smaller than negative 5. That should work. And this is 3 times x. So I'll just put this in parentheses because I'm going to multiply these. That means 3 times x, 3 times whatever x is. Here's my original inequality. And I have to choose something smaller than negative 5, like negative 6. Think about that. Negative 6 is smaller than negative 5 because it's farther away from 0. So 3 times negative 6. 3 times negative 6 is negative 18. And negative 18, we have to look, does that give me a true statement? Yeah, negative 18 is less than negative 15. So yeah, this is my solution to my original inequality. Now, let's look at this. This is where things get a little bit different. Just like I divided by 3 here, I'm going to divide by negative 3. Then we're going to cancel. And x, 15 divided by negative 3 is negative 5. But what you have to do is you have to switch the direction of the inequality. It's open to the right. I'm going to open it to the left. And now I have to test this again. Negative 3 times x, negative 3 times whatever x is. And I have to think, well, what's a number larger than negative 5? Negative 4 is larger than negative 5. And is that greater than negative 5? Greater than negative 5. Well, negative 3 times negative 4 is 12. And is that greater than negative 5? Yes, it is. Now, you might be wondering, why did you just switch the direction of the inequality? That is because I divided by a negative. If I didn't switch it, I would get wrong answers, like this one right here. X, if I didn't switch it, I would have x is less than -5. Okay, what's a number smaller than -5? -6 is smaller than -5, just like I did here. So -6, so -3 times x, I'm testing this now. -3 times whatever x is, which x I'm saying, okay, I didn't switch it. This is part of the wrong answer. So I'm doing the wrong stuff just to explain why I'm switching the direction of the inequality. -6. Is that less than -5? Well, -3 times -6 is +18. And this is a false statement. So if I don't switch the inequality, I get numbers that get solutions that follow a false statement. When I'm divided by a negative, I have to switch the direction of the inequality to get answers with a true statement. All right, this one. We have this one. When you divide here, you just have to multiply. The inverse operation is x is going to be greater than or equal to, because I have to keep that right there, 8, because 4 times 2 is 8. Super easy. When I have this, I have to multiply. Same thing here. I multiply again. X is greater than or equal to -8. Okay, so easy. And you have to make sure, absolutely have to make sure, this is the entire answer here. This is it. You can't just say 8. Of course, 8's an answer. Yeah, because it could be equal to, but also any number larger than 8. So if you just say, oh, Mr. Zare, the answer x is equal to 8, yeah, okay, but I want all of the possible solutions here. What could possibly happen here? Well, it could be 8, it could be 9, it could be 10, it could be 11, and so on. Well, yeah, I don't want you to just tell me what one possible number could work for x. I want all of the possible answers that could work for x. And in this case, any number that's larger than 8 or also 8 will work. Okay, so this, got it. And this one. Now, what I did is I have to multiply -4 times -2, and that is +8. And x. Now, here's the thing. Just like I divided by a negative here, and I had to switch the direction of the inequality here, I have to do the same because of this right here. I divided by, I had to multiply by a negative. That number right there, not that number. In fact, what I'm going to do is I'm going to erase this here because that doesn't have anything to do with switching the inequality. That one does. -4 times 2 is -8. All right, fine. But I have to switch the direction of the inequality because I multiplied by a negative. And that is the main thing. This is the only time when you switch. Everything else looks exactly the same as equations, and they work the same. Only you have to make sure you have the entire statement. Before, we could just say, oh yeah, the answer's 2, because that's the only number that would work. But in this case, anything bigger than 2 works. And I want to know, what are all my possible choices as a solution for the original inequality? So I hope this has been helpful in helping you understand solving one-step inequalities and what these solutions mean. Thanks for watching.